So today's lecture is about mainly types of encoding and the selection operators. So first of all, we know that the first step in genetic algorithm is we need to encode the chromosomes. We have the chromosomes and we need to encode these particular chromosomes. Firstly, what we do is we do the encoding. Now, basically, what is encoding? Encoding, we all know that whenever we are going to convert the original text into a different format of type, that particular conversion and process is called as encoding, right? You must have studied these particular encoding techniques, also different techniques. And in security reasons, when we do the cryptography, we call it as encryption, right? Now here encoding is, we have how many types? We have 6 types of encoding in the genetic algorithm. The first is called as the binary encoding. Second one as the octal encoding. Third, hexadecimal encoding, permutation encoding, value encoding, and tree encoding. Let's understand what these particular encoding are. First of all, binary encoding. See, I think you all know what is binary encoding. How do we do it? In this particular encoding, when we have the chromosome have a string of bits. Chromosome have a string of bits of what? Either 0 or 1, right? So we need to convert this particular into string of 0 and 1. Let's say if we have a number 10, how we are going to convert it into binary form? We are going to do the factors of this. Let's say we have 10, so 2 5s are 10, 2 4s 2 2 2 2s are 4, right? We get 4 here. This is like something. This is 2 2s are 4. This particular part is missing, right? And 1 will be remaining, right? 1 will be remaining, and finally 2 1s are 2. So what you get is, you won't get this, you get 0 1 0. So this is what you get as 1 0 1, right? So this is how you do the encoding. I think, let me check this again. This is 10, right? What we get is 2 5s are 10. When we have 2 2 2s are 4, here you get the remainder as 0, here you get the remainder as 1, and again you do as 2 2 1s are 2, right? Okay, so what you get is this one 1 1 1 0, and remainder is 0. So 1 0 1 0. So this is what you get as 1 0 1 0. You are going to start with from here. So 1 0 1 0. This is right. Okay, so this is the form we get as 10 and binary form. Next one is octal encoding. What is this octal encoding? In this particular encoding, here we were using in binary as only 2 forms, 0 and 1. In octal, we have 8 forms. That is represented in 0 to 7 values. That is 0, 1, 2, 3, 4, 5, 6, 7. So 0 to 7 there is that 8. So that is why it is defined as octal. So chromosome, let's say we have a chromosome A, so that can be defined with a string of 0 to 7, right? Third form is called as the hexadecimal. You all know hexadecimal is what? In this particular, you have a every chromosome is a string of from 0 to 15. As in octal, the chromosome is having a string from 0 to 7, and in binary 0 and 1, here we have from 0 to 15, that forms as 16. So here we know 0 to 9 is there, and then we have 10 as represented as A, B represented as 11, C represented as 12, D represented as 13, E represented as 14, and F represented as 15. So you can see this particular chromosome string, which is a sequence of 0 to 15. That is 0 to F, I would say, right? Not 15, because 15 is represented as F. Now, next type of encoding is called as the permutation encoding. This is an important encoding, and this particular encoding is basically used in traveling salesman problem and other types of problems such as ordering problems. So here what we do is, we have a chromosome which is a string of numbers, right? Which is a string of numbers. So we represent these numbers for this sequence. Let's say we define it as 1, 5, 3, 2, 4, 6, 4, 7, 8, 9. So these are defining as the numbers, and this particular is what? This is a chromosome A, which is a string of numbers. So this is called as the permutation encoding, in which we have numbers, neither the binary form nor the octal form and nor the hexadecimal form. Now, fifth type of encoding is called as the value encoding. In this type of encoding, we have the integer values. We have the values, which have the real values. So, in which chromosome, let's say chromosome A, so this particular chromosome is having 1.234. This is the value of this particular chromosome. 5.254, 0.455, 2.329, 2.454. All these are what? These are real values. So whenever we have a string of real values of a chromosome, that particular is called as the value encoding, right? Then next one, we have the tree encoding. Now, what is this tree encoding? Tree encoding is mainly used for evolving the problems or expressions for genetic programming, right? Whenever we represent the object or the functions in the programming language, let's say we have a particular programming language in which we are defining the loop, right? Let's say do while loop. So we are defining do until step this and wall define. So that can be represented as a T, this tree, this can be defined as this one, and then it will be branched forward. Here we can see that this particular expression is defined in the tree format, right? We all know how to be defined in the tree format. We have this particular representation as plus, then this is multiplication and division, and this as 5 and y value. So this is how this representation as graphical representation is defined in the form of tree. So this is called as the tree encoding. And so this is the last type of encoding. These are the 6 types of encoding which we have in genetic algorithm. Now we have second thing as the genetic operators. Now when we say operators, first operator that we have is called as the selection operator. So selection operator is the first operator in the genetic cycle, right? This is the first operator in GA cycle. Why this is the first operator? This is the first operator because the first operation we are going to perform is selection on the chromosomes. We are going to select the chromosomes, where we define chromosomes as the individuals, right? So what is the basic idea behind this? The basic idea is we have to get the better individuals out of the total population, right? Out of the total population, we are going to select the best parents so that they can give the give birth to a child who has a better fitness value. So a offspring can be created with better fitness value only if the parents are of good fitness value. So what do we have to define? We have to select the individuals as parents who can bring up the offsprings, right? So here what we are going to do, selection operator is the one which is going, in which the process of finding out the individuals as the best parents, right? So that is what called as the selection operators. Now here what are the chances? Chances are proportional to the fitness. That means we all know we define a fitness value to each individual. According to the fitness value, whichever chromosome or individual will have the best fitness value are going to be selected. Now in this we have number of types of operators, selection operators, which are used for different types of problems. So first particular type of operator, selection operator, is called as the roulette wheel selection operator. Now what is this roulette wheel selection operator? Roulette wheel is just like a you must have seen in like it is a form of game in which you revolve the particular circle, and in this there is a pointer and the pointer gets stuck to somewhere, right? We just revolve this wheel, and wherever the wheel is pointed towards, let's say the wheel is stopping at B. So B is to be selected as the one of the parent. B is selected as one of the parent. So this is called as the roulette wheel selection, in which what we have assigned to each individual a part of roulette wheel. We define the roulette wheel in which each, let's say we have 3 chromosomes A, B, C. So we give a particular partition of A, B, C according to the fitness value. So let's say what we have in A, we have 3, right? So 3, the total is 3, 1, 2. So it is 6, right? This is total is 6. Total is 6. And for A, what is the probability? For A, it is what? 3. The fitness value for A is 3. You can see it here. A fitness value is 3. So 3 by 6, this 50% is defined for A. So 50% of the wheel part area is defined to A, right? It is covering the maximum. Then the fitness value is 1. So let's do it again. 1 divided by 6. So that defines as 17%. So B is given as only 17% of the area in the wheel. Then we have C. C is 2. So 2 divided by 6, again it is 33%. So C is given as the area of 33%. Now you can see 33 plus 17 plus 50 is what? Total 100%. Now you can see that whichever has the less area coverage will have the lesser probability for the spinner to get stopped at the pointer, right? Because it is covering only this much area, so it will have the least probability. A will have the maximum probability because it is covering the 50% area. Let's say if the wheel stops at this particular point, then A would have been selected. So this is the how we are going to do the, we are going to spin the wheel n number of times to select n individuals, right? So basically what we did is parents are selected according to their fitness function. The better the fitness, more chances of getting selected. So how do we calculate the probability? We calculate the probability. Let's say Pi is equal to Fi divided by summation j1 to n Fj. What does this mean? This means that whatever the total number of fitness we have, let's say we have n number of individuals, we are going to add the fitness value of n individuals, right? That we did here. We have 3 individuals and we added the fitness value of 3 individuals. 3 plus 1 plus 2, so 6, right? And then the fitness value of that particular for which we are going to calculate the probability. Let's say I'm going to calculate the probability of A. So PA, right? It is, let's say, PA. So PA is what? PA will be, this is Fi, this is Fa, yani fitness function of 3. Fitness function of A is equal to 3. So 3 by 6. This is how we are going to calculate. So this is the basic formula behind this, that we have given you the idea how the probability is going to be covered. So here Fi is what? Fi is the fitness value for the string, n is the population size, right? Now we have second one is the Boltzmann selection. Boltzmann selection is a specific and a mathematical expression which we use. It is used in simulated annealing. This is a method in which we do the function minimization or maximization. So what you have to remember, just the formula of this, in which we have the probability of E is equal to expression minus E divided by KT, where K is what? K is the Boltzmann constant. So this particular method is used for functional minimization and maximization. Now moving to the third selection operator. The third selection operator is called as the tournament selection. Now you must have seen so many tournaments. What is the actual way of doing the tournament, playing the tournament? It is, firstly, we define randomly, we select who two will be the teams who are going to play against each other, right? Let's say we have three and these particular are, let's say we have 3 matches, so 6 teams are playing. So out of these 6 teams, we'll get 3 teams. One will be the winner of first match, second will be the winner of second match, third will be the winner of third match. So out of 6, we can select the 3 teams, and then again these 3 teams can have the match together, right? So 1 and 2 can have the match, again the winner can have the match with the third. So this is how the tournaments, and then we get the final winner. So this is how the tournament selection is done here, and same way we are doing it in the chromosomes. What we are doing, we have these particular individuals. Let's say we have 1 2 3 4 5 6 7 8, and these are the fitness value: 1 2.1 3.11 4.01, and so on and so forth. Now first step is what? Firstly, we are going to select any two individuals randomly. Just remember, don't get confused how we are going to select the initial individuals. We are going to select the uh, individuals randomly. So let's say we have selected 2 and 4. Let's say we have selected 2 and 4 randomly, right? So out of these, who has the better fitness value? 2.1, 4.01. So 4.01 is a better fitness value. So who wins? 4 wins. So 4 is the winner for step 1. Again in step 2, we can randomly again select any other two individuals. So here we select 3 and 8. Now you can see out of 3 and 8, which one has the better fitness value? 4.55. So 4.55 is the winner. So 8 is the winner. So here 8 is going to be the winner. In the next step, we have taken as 1 and 3. So 1 and 3, 1 is the fitness value for 1 and 3.11 is fitness value for third. So here 3 is the winner. So what we are going to do again, now we are going to select these two and get the winner, and finally we get the winner. So this is how the tournament selection takes place in genetic algorithm. Now next one is the fourth one, that is called as the rank selection. Now what is this rank selection? It overcomes the problem of rowlet wheel selection, and rank selection is the one in which the population receives the first ranking who has the best fitness function, right? And worst will have rank 1 and further. So here what we are going to define, we are going to provide the rank to the each individual as according to the fitness function. Next one, we have the steady state selection. Now in steady state selection, what we are going to do, we are not going to do any random selection. We have a specific method in which we are going to select the individual who have the high fitness value, that we define as good chromosomes. The individuals who have the good chromosomes means high fitness value, are going to be selected, and we are going to eliminate the bad chromosomes who have the low fitness value. So no random selection, no any other selection. Just according to the fitness function and fitness value, we are going to select or eliminate. So that's all for this particular lecture. Thank you very much.